and I know probably some.
All right, so I don't know if the audio is working. I mistakenly went ahead and oh, it is working. Let's go. Hold on, let's make sure. Right, so I don't know if the audio is working. The audio is working. You're gonna hear double me saying that, but that's just a check. So today, what I'm doing and what I've been doing. Well, I started earlier. My main goal is to keep continuing to learn C++, and the easiest way to learn C++ is by blueprints, which is this visual scripting. Let me show you guys my screen. It's this visual scripting thing that they have in Unreal. It's what you see here is where I would put blueprints. Like if I want to do something every frame, I would drag it out and say do this every frame. It'll just print the string hello every frame. And you'll see when I press play, it's printing hello every frame. But you can also do, come on, Sonia, you get a notification. You can also do this in C++, which is, let me just open up that. Uh, inside of here. Basically, what I'm doing now is taking mechanics that were already made in Blueprint and converting them to C++, which is more efficient. And it's just more future proof, basically, for game development. And me being a weird person, I want to learn the language. Like you can make a full game in Blueprint. Like it's been done, and I've actually made a game or two in Blueprint, but it's just not professional. It's not the professional standard of making games. All right, so what we are looking at here, if I move my face out of the way, hold on, let me move that somewhere over there. Yeah, there we go. Yeah, so yes, what we're looking at here is C++. It's basically everything you can do inside a blueprint, but it's faster because it gets broken down to machine code. Blueprint gets broken down to C++, then gets broken down to machine code. So, without further ado, let me get to the main meat of what I'm doing. I am taking a tutorial that is written completely in Blueprint. As you can see, this one is already 20 minutes in. I'm taking this tutorial on advanced wall running, which is a mechanic that I want to include in the game prototype that I'm making. I'm converting what he's doing in Blueprint to C++. And this is how I'm teaching myself C++. Um, so I've already done the beginning of his tutorial, which is just implementing in the double jump. Oh, gotta turn that down. So the double jump is there. Pay no attention to this gun. This game is not gonna be about guns at all. But yeah, you can see the double jump is working. And the next thing, I didn't compile this. That's why I still doing that. The next thing that I'm trying to do is just continue with what he's got going. So what you guys are gonna get, you're gonna hear him explain something in C++. I'm gonna take it and convert it. I mean, you're gonna hear him say something in Blueprint, and I'm gonna take it and convert it into C++.
You guys are freaking out right now because a lot of people freak out whenever things happen, even at Tick, which is understandable. But this is this will have a check in it, and most of the time it will just return very early, and nothing will actually happen. So there's nothing to worry about with that. So
let me know if the fan is annoying,
and we will fill this out. So the first thing we want to know is our early out. We only really care about clamping the horizontal velocity.
I'm gonna let you guys watch this too, so you understand the differences.
If we are in the air. So grab the character movement component and check if we are falling. And if we are falling, we will do stuff. If we're not falling, then we won't do anything. So like I said, most of the time, this won't run. And even when it does run, it's very, very little code. I promise you it does not matter much at all. Okay, so we want to constrain the horizontal velocity. So the first thing we want to do is to get the horizontal velocity. And we have a little handy dandy function here for getting the horizontal velocity.
Which is not.
But we haven't filled it out yet, so now would be a good time to do that.
Alright, so I'm going to get caught up to where he is now in C++. So in the tick function, which I don't have yet because I don't have it written in here, which it should be in protected. So it'll be virtual void tick, and that takes in a float delta time. So what he's doing is checking every frame to see if something is true or not. And what I'm going to do is the same thing. So basically he said, what was that variable that he used? If we are wall running, I think B is wall running. We're going to do something else. We're not. So that's how simple it is to write just what he wrote right here. Oh no, I'm tripping. So he got the character movement component and then checked to see if we were falling. So here I gotta get character movement, which is a function that's already written in C++, and get is falling, which is another return function. It returns a boolean, which is, so if function checks whether something is true or false. That's it. So whatever in here has to, whatever is inside of these parentheses right here has to return either a true or false boolean. So this is if the character is falling. So we continue, and he's also getting the horizontal velocity, which is a function that I already wrote. It's right here. So I kind of, did some bullshit to. Is this not done parsing already? What the fuck? Why is this in purple? Okay, I don't know. I don't know why my variables are showing in purple. Let me build this real quick. This is why people don't do things in C++ because it takes a pretty long time to build. But I'm not understanding why these are in purple. I hope that's not a bug, but it built properly, so we should be good. I guess it'll catch itself up whenever it's done parsing or whatever. So yeah, get horizontal velocity is the function that he's about to write right now. So let's go.
Just get the character movement component, so you can just drag in. Get the velocity, not that. Get velocity at the bottom. And we want to convert this to a vector 2D. And this will basically get rid of the z, or the up component of the vector. And then you can just drag off of this onto here, and it will add a return node for you.
Y 2D. Okay, so this is actually going to be a vector. I gotta change that. F vector 2D. This is called, what could we call this? This is the horizontal velocity. So it's giving me some issues right now because this is not matching up with what I called it in the header file, which is easily changed. Just go ahead and call this void and plug in this F vector. And if anyone has any questions on what I'm doing, let me know. I could try to explain everything that I'm doing, but I'd rather just push on through it, you know what I'm saying? Because these tutorials are like 20 minutes, but converting a tutorial that's 20 minutes in Blueprint to C++ could take 40 minutes or an hour. So I call this horizontal velocity. Horizontal velocity. Hell yeah, if you want to code, you have to learn how to type at least 30 words a minute. Because if not, you're going to be you're going to lose. Void, get horizontal velocity. I'll put in a vector. So this is what's bothering it right there. Yeah. So, in short, what I wrote, and this is what's confusing about C++ syntax, is that this is returning nothing. When I first wrote this, I was returning a vector, which is a x, y, and z coordinate. But now it's returning nothing, but it's still outputting a variable. So it kind of is returning something, but not as its main. It's not its main job to return something. It only does a return after we calculate some things. Excuse me. So yeah, that's what he did right here is exactly what I just did right here. I know some people are like, bro, I'd rather just do Blueprint. But the thing is, if you write it in C++, you can do it in Blueprint as well. And if you're making a big enough game, you're gonna have to go to C++ eventually, anyways. So it's better to just write it in C++ first and just set everything up in C++. That way, when you trickle down a blueprint, you're not having to go back up the ladder. You can only go down the ladder. You know what I'm saying? So that's good.
Why it doesn't actually hook it up, I'll never understand. All right,
Yeah. So,
and so
oh,
that's that.
I forgot to get the character movement component and change this velocity to a vector 2D. So basically, what he is doing is kind of like this vector. Um, let's call this temp velocity, and we'll leave that at the top. So basically, he's going temp velocity is equal to the get character movement component, and he's getting the velocity. Not velocity, yeah, right there. And then, so what the ultimate goal of this is to output just the x and the y coordinates of this to a vector 2D. So I would say horizontal velocity is equal to f vector 2D, and I'll fill in these two x and y coordinates. So it'll be temp velocity dot x and then temp velocity dot y. God, looking at this, bro, I know that it doesn't make any sense to people watching this shit. Like, it's like, what the fuck is he doing? Why is he even streaming this? Yeah, so why? I don't know why that's purple. That's yeah. So local var. What this is? What the fuck is the difference here? Vector x vector x component, and this is the vector's y component. Okay, so that's right. Okay, so we have currently outputted this here to a horizontal, to this right here, which I think I actually should return. Nah, I don't have to. Okay, we'll keep going. What's good, Max, bro? I was just saying how none of this shit probably makes any sense to anybody watching except probably you.
That gets our horizontal velocity. So now we'll go back to the clamp horizontal velocity function, and we will finish writing that. So now we can actually call get horizontal velocity, and we want to get the length of this,
Okay.
and vector 2D length. And the length of a vector is
like the float.
Is basically the speed of it in this
It's
case.
the only way I learn, brother.
Because if the velocity is super high, then the length of it's going to be super high as well. So this is basically the speed that we're moving in the horizontal direction, which is what we want to clamp. And we're going to want to divide this by our max speed. So
okay. So just to explain what this dude is trying to do. This function that we're writing is called clamp horizontal velocity. So a bug that was found when you have like more than a double jump is like you could like jump and keep jumping and keep boosting your speed up like to infinity basically. And you know, when a game is dependent on everybody having the same thing, I mean that's kind of unfair. Even though everybody would have it, it's still kind of unfair. It's like a bug to abuse. It's not intended in the game. So what we're doing right now is clamping that velocity so that it doesn't go over a certain amount. Now, the way he's doing it is different from how I thought about doing it. I wanted to just, whenever you release the key, would be to reset the velocity back to the default. But I'm guessing this is combating, like, if you want to change the max walk speed in the future, you won't have to go back all the way to the function where you're setting it back to default and changing that. You can just change the max walk speed, and this function will adapt to that number that you use, which would be good, because game development is all about testing numbers and shit. Is from what I've learned. So we're calling this function inside of I forget. No, it's not set. Clamp. Inside of clamp, yeah. Or is it clamp? No, it's not clamp. See, it is. It is clamp. So where the fuck did I write this logic at? In the wrong spot? I did. I wrote it somewhere random as fuck. Because here's my clamp horizontal velocity. Where did I write that? That's gonna piss me off. That's gonna piss me off. Okay. Let me just go back. Get horizontal velocity is where this is. Okay. And before that, in clamp. But I wrote this somewhere completely different. Does anybody remember where I wrote that? Let's see if I can find it. I didn't do it in there. I don't think I did it in the hero jump. Did I even write it? Oh, I wrote it. Yeah, I wrote it in here. No, I didn't. Okay. That's something else. That is actually weird. Did I even write it, bro? Alright, so let me close all these functions that I haven't wrote. The shittiest thing about C++, right, is so if I pre-write functions over here, I have to create an implementation for them in the C++ file. To get, even if it doesn't matter, I have to write the implementation over here to get the code to compile so that I could test what I'm actually writing code for. Nope. This is for later. All this shit is for later. So it's confusing because I thought I did write the if statement, but I guess I did. I really feel like I wrote that if statement. Like, but hey, fuck it. Fuck it, you feel me? We'll find it later.
And we basically want to cut back our horizontal.
Okay, so where we are, oh shit, I skipped way ahead. So now he's getting inside of get horizontal velocity or what does that sound? Inside of clamp horizontal velocity, he's getting the character movement, checking if we're falling, if that's true. Not, we're doing something else. I swear to God, I wrote that, bro. I wrote that somewhere, but it's not. So we'll just go right inside of here. So it's an if statement. If you hit the character component, character movement component. And because the reason I know that I wrote this is because I explained it. Is falling. And that has its own thing. So if this happens, we do something else, we do something. So here we are supposed to be getting get the horizontal velocity, which is outputting a here. Easiest way to do this is to make my own F vector 2D to output to. So we'll just call this out horizontal velocity, right? And we'll plug that in right here. So whatever we were outputting in the other function, we'll put into this vector right here. What's good, Rico? Oh, that's B. I'm tripping. So yeah, all this does is get this F vector 2D and outputs it basically into horizontal velocity. Then we take that and we put it in a temporary variable that we're going to use, which is this bad boy. And then we can call, what do you do, out velocity dot size, or is it length? No, it's like size for this. And they probably need to change that. Right here, they need to change this. This returns a float. Yeah, okay. So we're in a good spot.
Finish writing that. So now we can actually call get horizontal velocity, and we want to get the length of this and vector
Which is
2D
size
length.
in C++.
And the length of a vector is basically the speed of it.
Okay, and that's another thing that is a lot more difficult than say no, it's a float. Float out speed, and we can instantly make this equal to dot size. Here, we do this right here because we need to do this all before there. And get rid of that. So basically, we just set up the variables that we're going to use in this function, and what he's about to do is all happening under here.
In this case, because if the velocity is super high, then the length of it's going to be super high as well. So this is basically the speed that we're moving in the horizontal direction,
Here.
which is what we want to clamp. And we're going to want to divide this
So we're dividing the
by
length
our
by
max
the
speed.
max speed.
So
okay, by the max walk.
get character movement component.
You see how simple it is in Blueprint? Like fucking drag and drop. But we're not here to learn Blueprint. So we get the character component. Oh, we get the character movement. And get the max walk speed. That is a float that we can use. I gotta kind of keep watching, but I'm kind of just trying to write out all the variables that he's using. So basically, we're going to take outspeed, and divide it by this. And we're going to input this into some variable right here. probably float, current, velocity equals outspeed divided by float. Yeah, something like that. Program is
So there's a
confusing.
get
I'm
max
telling you.
speed and there's a get modified max speed. I think we want get modified max speed because uh,
Add a
there's like a
modifier to
modifier
it.
that you can add to it. So
Okay. Cool beans. So just change this to max. Modified. Hmm. Modified max. Get modified max speed. There it is. Is that a function? That is. Holy moly. Sorry, I keep swapping back and forth.
this will account for that.
I'm
So
gonna
we
just
want to
bring
divide
that
that
over
by
here.
our modified max speed, and we want to check if this is greater than 1. And if it is, so this is basically checking, like, are we moving too fast, is what this is checking.
So he's doing this he's doing this check only if this shit is true. God. Cool.
And if you think about it, the reason that's true is because
Well, I guess every frame we should be calculating this, right? And if it's true, if this is true, we should be worried about this current velocity being greater than 1. So we can do that right now. If this current velocity is greater than 1, we do some fucking magic. Okay.
so say that our horizontal velocity is 10 and our max speed is 5. Well, 10 divided by 5 is 2, which is greater than 1. So we're moving too quickly. And if we're moving too quickly, then we basically want to cut back our horizontal velocity. So we're going to call get horizontal velocity again, and we're going to divide that by whatever this value is. So in the example from before,
So if this is greater than 1, then we are going to see. He's dividing f vector to the. Oh, okay. We can just divide out horizontal velocity by 1. Okay. Divided by 1. Right. And I'm pretty sure. Okay,
our
hold on.
horizontal velocity was 10, and then this is 2. We're going to divide 10 divided by 2, we're going to get 5, which is exactly what we want, which is our modified max speed. And now that we have our clamped horizontal velocity, we want to call this set horizontal velocity function, which we also haven't written yet, but it's pretty straightforward. So we will go ahead and do that right now. So just double click on it. And from in here, we simply want to set our character's velocity, but only horizontally. Well, before we do that, we need to add an input pin.
Okay. So set horizontal velocity. Where are you, shorty? Oh, sorry, you guys aren't watching me even type code. I've been typing code this whole time. Set horizontal velocity right here. This needs an input. It's gonna take a f vector 2D called horizontal velocity. And let's go to this definition real quick. IntelliSense, bro. Oof. This would be the reason I go to Ryder, because Ryder is eons faster than this shit. But this is free, so you really can't beat that. What? Why is it saying that I don't have it? Bitch. Can we peek? Go to declaration. No? Peek definition. Bitch, that is the same. Okay. They about, oh, because it doesn't have one. Okay. Understood. Understood. That's my bad. That is my bad. So I gotta find you here. Set. Look for the one with the error. Okay. Get rid of that. So first thing he's doing is getting the character, the movement component, and I'm pretty sure he's getting the velocity. And we could just put that into a temporary variable. Temporary variable for now. Velocity. We can say a vector. What would we call it? Temp velocity is equal to this. And then we want to break down temp velocity and put in the F vector, or we want to put in horizontal. I'm just thinking about what he's going to do. So basically what we're going to do is take this temporary variable that I just made right here, just so we can break it and put in the X and Y from here, and then remake it and set this to this again, which is weird, but that's how the shit works.
Which is a vector 2D.
Let's just make sure.
And it's going to represent our
Hey,
horizontal velocity that we want to set. Horizontal velocity. All right, so character movement, we want to set velocity.
Oh no, it's just.
But again, we only
velocity.
want to set the. Oops, we only want to set the horizontal velocity of it. So if you come in here and you right-click on velocity, you can split it. So you can do the X, Y, and Z components. And we also want to do the same for our input pin here. And so we want to drag the X over to the X and the Y over to the Y. But the Z we don't want to.
Okay. So, where are we? Look, bro, it should delete. I wrote it inside of tick. That's where. No, I don't want to build that. Oh shit! Excuse me. At least I found where I wrote that wrong code at. I was just setting the horizontal velocity. There we go. Alright, so this is the function. Set velocity. It's not there. Okay. Set. Oh no. So there's not. Oh, okay. I can just do this. Velocity equals. I'm an idiot. I was panicking for a little bit. I was like, oh fuck, I'm gonna have to go to Google and look like a fool. Um, let's just call this f vector, right? Oh shit, f vector here. We create our own, right? So the x is gonna be horizontal velocity dot x. The y is gonna be horizontal velocity dot y, and the z, God, I'm European now, is gonna be get character movement. And whoa, we're not done there yet, brother. Dot velocity dot z, so we don't change it. Okay, that looks about right. And then I need to call this right here. So I need to call set right here. So I would set horizontal velocity, and then the vector, yep, it already knows. The vector 2D that I would pass in would be this one. So it'll take this information, plug it into here, these two, and this will stay the same. I'm teaching myself while I'm talking about this, guys. So don't pay me any mind.
Change, but we also don't want to set it to 0. So we want to get the current velocity. And we want to use, we can split that. We want to use its z value because we don't want to change the z value. We only want to change the x and the y, which are the horizontal values. Okay. So now we have that set. We can go back to clamp horizontal velocity, and we can hook that up like that, and hook that up like that. Okay. So now, just to recap again, this will get called every frame. If we're actually falling, then we'll check if we're falling too fast. If we're falling too fast, then we will reduce our velocity, or our horizontal velocity, by however much we need to so that we're not above the max velocity, and we'll set that. And so back in event tick, or event tick. Okay, so I did hook that up. So let's go ahead and see if that fixed it. So now we can jump left as much as we want. And you can see we're not getting super fast. But we can also kind of go back to the right if we want to. Very similar to how I see it in games. So now you have a lot more control when you're in the air. And again, I bumped this up to 6, the max jumps.
Okay. So before I get up out of here to test, I need to set B primary. Oh, I forgot what that fucking variable is called.
But normally we're...
And this is why coding is a literal... Let me let y'all see what I'm researching here. So I gotta see primary beacon tick, basically UE4. I forget what the syntax is. C++. Set an actor tick. UE4. C++. Do a lot of this in coding. Anybody that thinks that they know all this shit in their fucking head is kidding. If you do, hey, you've been doing this shit for 10, 15 years and you're writing the same code over and over, hell yeah. Me, I've been doing it for 10, 15 weeks. So I gotta go where is that at, bro? Like, and the thing is, you have to know the right answers to ask too. But if I go to another, which is good. Let me go right here to see if it's been called in there. Damn, they didn't even call it in here either. Nope, not in there. Let's check the game mode, maybe. I'm pretty sure the game mode ain't ticking. We can check though. Nope, it's not. I gotta go to. Get rid of this shit. I gotta go to a whole other project to check and see what the fuck this function is called. Get in there. Let me get in there. I think I did it in here. Yeah, I definitely did it in here. Let's go. Private player character. What the fuck? It's empty? No way. Character base. Maybe that's it. Primary actor tick dot B can ever tick. This is what I was listening. This is what I was looking for. Oh shit! Don't want to do that. Mess up that whole project. Primary actor tick dot B can ever tick equals true. You have to set this so that you can use the tick component or the tick function. Okay, we're looking good. Let's see if that builds. Ooh, missing this before. Oh, yeah, okay. Thank you, compiler. Uh-oh, what was that? Warning, you movement component get modif is deprecated. Use get max speed instead. Okay. That's line what? 252? We've already written 252 lines of code, bro. Get max speed. Alright. So that should get rid of the warning. We don't want none of that. Whoa, 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 whoa. Why not? Line 1. Okay, let's go into the did I crash the project? Hell yeah. God, Unreal, you gotta get over that shit, bro. I'm just compiling C++ code and the shit is crashing. Okay, let's see if that compiles. Hopefully we don't crash. We're good. Alright, let's test if everything's worked. No. It's gonna crash. That's going to crash. What the actual fuck? I don't know what that is. Okay. So it compiled, but something's wrong. I literally think it's this. The fact that I'm calling that every frame. So say I don't call this, right? This is how you figure out problems. You eliminate what you added real fast. It builds successfully. And my jump's not fucked up. Yeah, see, okay. Yeah, I did all the proper checks, if I'm not mistaken. So the first check is to check and see if we're falling, which we would only be falling if we've jumped. But I think that this is happening too fast. Like, it's doing this too fast. I'm not gonna do this right here. I'm gonna do max walk speed variable. I'm gonna call it again inside the tick, which tick should be like here. We're almost on episode 3 where we do the actual wall running part. So it's about to get real tight, boys. Okay, since I was doing max speed, I guess it was doing something. Ugh, my air control is whack. Okay, so another way to test this is to set max jumps to, let's set it to 6. Right. Let's build that. Play. Oof. Better crash. What the fuck? That's so weird, bro. I literally don't know what the fuck that is. Okay, so 6 jumps is not too bad. But we definitely can't have that in the game. So that's 2. I really wish that it would stop, you know what I'm saying, like glitching out. Like right here. Like why is that glitching out? Why? Why do I have to compile inside it? It's not hot reload. I don't think it's hot reload. Yeah, it's not hot reload. So I'll just compile the code inside the editor from now. So yeah, okay. So double jump still works, and we've clamped the uh the velocity on the horizontal axis. And I should say more than the horizontal axis. So in here, just to make sure when we crash again, we don't lose anything, we say clamped X and Y velocity while jumping. Fix the bug when we were jumping more than 3 times. issue. You have to make sure you really take care of these things. Like, I've gone through 5 hours of not committing, just doing shit, and then the project crashed, was corrupted. Had to go back 5 hours in time during a game jam. Not good. That's not good for any of us. So we just gonna make sure we document everything well. Hey, I appreciate the retweet on Twitter because I'm doing some. Let me see. I'm not paying attention to the oh shit to the Twitter right now. But if there's some nerds in here, that'll be cool. No, there's not. There's one. Oh no, that's me. We'll leave it here just in case people jump in. You know, I'm hopeful. So yeah, that is that.
We're gonna keep it at 2, so I'm gonna change it back to 2 now that we got that working.
Got it working.
All right, so that pretty much concludes this section. In the next section, we'll go into the actual wall running of it.
I want to let y'all know. Look, man, when I say, y'all probably looking at this shit like I'm not doing nothing special. I'm just copying some shit. Bruh, a few months ago, I didn't even know what to write. That's the funniest shit, bro. Like, I couldn't have put any of this shit I'm putting together right now. I couldn't have put any of it together because I didn't understand this language at all, bro. Like, at all. And I need to minimize this. That is not important right now. So, let me just let you guys in on the little stuff that I've learned about. And I could probably put this in the region. Yeah, I'll put this in the region. Get rid of this stupid thing right here. I don't know why they don't use regions in here. That's the one thing I miss about fucking Unity. Region. Input right here, and then we'll just go right underneath it. Pragma in the region. Right there. Boom. Okay, so yeah. Now we can put this in its own little, you know what I'm saying? Its own little cul-de-sac here. Ugh. It's got its own label there. I got another one down here for movement. I could probably take this and just let's do sound effects for my game. We got input, we got movement. This is my oh yeah, that's gonna come in handy later. What's good, cuz? So yeah, we got this function out of the way. This, and we just leave some comments here. The velocity on the x and y axis. So weird speed boost happening. Alright. So yeah, that's for this function. I'm actually gonna make a region right here just to keep myself organized. This is very important about code. You gotta make organization habits. So we'll call this my timelines. And then underneath this one, we'll go ahead and end that region. And you gotta have strong forearms because coding is a bitch. So workout. Alright, so we'll just move you underneath this. Whoop, whoop. Probably not gonna need this right now, but I'm gonna leave it for just now. see how tighter the code looks? Like it looks tighter. Like I don't have to scroll a fucking 2 pages just to get to something. That's just me. Other people might like this shit different way. Okay. On wall returns a bool. I should put all my returns close to each other because I put them inside of a region. Return void, return void. Yep. All right. So
All right, well,
now we're moving on to actually getting. Yeah, it says in this tutorial I'll be showing you how I implement it. Oh, in one of his games. I want to play this game.
welcome to part 3 of the wall running tutorial. In the last tutorial, we got our double jumping working with a lot nicer control when you're in the air. And in this one, we're going to actually start on the wall running specific logic. So the first event we're going to tackle is on component hit. And again, this gets called whenever our capsule component hits something, like a wall.
Sorry, forgot I filled this out. I'll put the current X and Y velocity in F 2D. Okay. Can I do anything else? This here as well. Our custom. Say our like it's more than one of us. My custom jump function. This here sets the remaining jump to the maximum jump. I appreciate anybody that comes in and like checks in on this shit. I know it's weird, but hey, man, this is what I'm doing. Like, this is my life now. This is my life now. Like, learning, trying to teach myself, trying to teach others, and just bringing awareness on shit like this. This shit looks like alien language to my. I guarantee you, anyone with my color of skin is looking at this shit and thinking, what the fuck? Okay, so this returns. Okay, I need to definitely label this one. So this returns the vector our character will use to jump depending on which direction is in direction is given with the input. So this returns the vector our character will use to jump, depending on which direction is given with the input with the controller input. All right, so let's go ahead. Let's go.
So the first thing we want to do is if we see we hit something, we want to check if we're actually already on a wall. And did I fill this out already? Yes, we did. Okay. So if we're on a wall, we don't want to do anything because we're already on a wall, and
Do I
that's
have
where
this
we want to be.
Let me make sure I
So
don't have this dumbass function that he wrote. I don't know why he wrote on a wall, but I guess it's to make the code look better. Yeah, yeah, I do have this. I do, and all it does is return. Yeah, I don't need this. I don't need this function at all. Do I use it? Like, let me see. Um, let me see. Control F. Let's just look for on wall. That's the function. And that is the header. And that's it. Okay, yeah, I can delete this shit. I'm not using this. I'm not using that. I don't need that. It's literally just returning. Yeah. Bitch. I could just put an if statement. I'm not doing that shit. And there's certain things people do in Blueprint that's not necessary at all in like normal code, but they do it because it makes Blueprint easier. But for me, hell no, I don't need a function that just returns a boolean that I could just check the boolean. So the first thing he's checking is if we're wall running. So we just check if this is true. If it's not, then we'll do this.
if we're not on a wall, we're going to want to do a branch here. And that branch is going to be whether or not we can actually wall run on whatever thing we just hit. So we have this function for can surface be wall ran that we need to fill out. So let's go ahead and do that next. So if you double click on this,
and it returns a boolean. But it intakes, if I'm not mistaken, for my notes, let's look it up. Is surface wall runnable? Right here. It returns a bool. Okay. And you need to go up there with the return function. So let's boop, 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 boop. Sorry, I don't know why I want to do that whenever I just seen another one. Bool, bool. What's my other one? Okay, we'll just keep it here. Bool F vector bool. There's another bool somewhere, but it's not here. Oh, on wall. I deleted it. Yes, I did. Yes. Okay, so we go inside of here, and look, I took notes, so I'm gonna try to do this one without his step-by-step instruction because I kind of remember this one. Here we take the cross product. Hold on, let me. Is wall runnable? Check wall logic right here. Look, man, this is serious. You see this? I don't know if you can see this. Yeah, I'm gonna hold it up. But yeah, excuse my handwriting, but you know, I'm not a calligrapher. What is it? I don't know what that professional job is. I don't know what that job is. Let's just put this right here. So we already bound our own component head function. We already bound our own on component hit function. So when I check here on something that's hit, it's actually, this is tethered to a function that's already included with this character capsule component. It checks to see if we hit something. So whenever this gets called, it's going to dynamically call this, which is what I'm filling out over here. Okay, so first we want to check if the z value of the input is less than okay, check if the z value of the input is less than negative 0.05. Oh, I checked to see if the value of it. I'm an idiot. Okay, so first we do this. We check if the value of the surface normal dot z is less than negative 0.055 f. Let's just do that. If that's true, we return false. The wall is a roof. This means that the wall is a roof, or it's the ground. All right. Now we need to make a new vector using the x and y values of the input and normalize it. So we make a vector 2D because we don't, or we just keep the vector at 0 for the z. Okay, I will need to see what he did because my notes.
The first thing we're going to need to
scratch.
The first thing we're going to need to do is add an input pin for a vector, and it will be called surface normal. So this is the normal of the surface that we hit.
I got that
far.
far.
We'll be able to figure out whether or not we can run on it or not. So let's go ahead and take this vector and break it into an x, y, and z component. And the first thing we want to check is that the z value of it is less than a certain value. And basically, this is just checking that, you know, we're not colliding with the ceiling. So if this value is less than 0, or maybe we should use negative 0.05, so that there's a little bit of a threshold, so that if a wall is slightly tilted, you can still wall run on it. But anything beyond that, we don't want to be running on walls that are, you know, like ceilings. Basically, we don't want any of that. So if it's less than 0, basically, then we just want to return false, because we can't roll.
Who's
wall
in
run
here?
on it.
Who's in here?
So we will return.
Appreciate you guys
we need to add
sharing
an output
this,
pin
liking this,
for a
man.
boolean.
Like I said, I know.
And
Hey,
yes,
babe.
it defaults to
I
false,
see
so
it's
we're good.
you.
So that's one check, but we're not quite done yet. We also got to make sure that it is not walkable. So like the ground, for example, or like a very small incline, we still don't want to be able to wall run on that because we can walk on it. So why would we wall run on it? So to check that, we're going to want to make a vector. Make a vector off of these x and y. So this is basically just the x and the y components. Sorry, I'm just cleaning this up. X and the y components of the surface that we hit. And we want to normalize this, so it's a normal.
Mm-hmm.
And we want to take this
and put it in a
dot product with.
Okay. Okay. So this is an else if. Else if. But we have to do this outside. Yeah, okay. So F vector dot vector equal to F vector. We'll plug in surface normal dot x, surface normal dot y is 0. Shit. Okay, and then we need to do F vector dot product, which we put in the dot product vector that normalized. We know it's a function. Okay, so I guess we need to normalize it up here. No suitable constructs that exist to convert from bool to F vector. Huh. All right, gotta go to Google. Oh, I gotta get the safe normal. The other. What is the other? It's the wall run side. It is the wall run side. I swear to God. What is it? Let me check my notes. It includes the. Oh, okay. It includes the original input and the one that we're putting in here. So, and then we'll put in surface normal. Come on, dude. Get out of there. Okay. Progress. Slowly but surely. Yeah. So dot product, which I still don't even comprehend that well right now, but this gets the. I don't think it's the perpendicular. I think it is the perpendicular angle of these two angles, the normal that we hit and I don't know. Like, I can't explain that to you. I just seen it work, and this is why I'm studying this shit because it makes my mind go. I don't really know. So yeah, let's keep going.
with the original surface normal. And I'm gonna do that so it looks kind of pretty. And basically what that's doing is it's giving us the slope of the wall. Um, the slope of the wall like on the z-axis, if that makes sense, sort of. So if the wall's too steep or not steep enough, that's what it will tell us. And from the
We're
dot product,
checking
we
that.
want to take the arc cosine, which will give us the angle of the wall in degrees specifically, because we can compare that to
Sonia? Hmm. Looks like I need to include this to do this next one. 'Cause, so, Kismet Math Library needs to be included for this next thing. So float wall angle is equal to, what is this? It is U Kismet Math Library. Grid coast. We plug in the wall slope. Okay. Simple enough. Simple enough. Okay. Continue.
something inside the character movement component called get walkable floor angle,
And we're comparing these two.
which is a thing built in to Unreal. So this is basically the max angle, like 45 degrees probably, that the character can
And then we're
walk on
checking
before
else
he starts
if
sliding
this is
off.
greater.
So if the slope of the surface that we hit is less than the max floor angle, then we want to say, hey, yes, we can walk on it. So, or sorry, we can wall run on it.
Angle
So we will add a return
is less than get character movement.
won't return node
That's
like so,
max.
and that will get hooked up
Walk.
to the false like so.
What's that called? The
So again, just to recap,
walkable floor.
the first thing we just check is a pretty
Yeah,
simple early out,
walkable floor
saying
angle.
like if this wall is basically a ceiling or it's slanted towards us basically, there's no way we can
We
wall run
return
on it,
true.
so just get out. But for all other walls, we just want to make sure that we can't actually walk on the wall, and if we can't walk on the wall, then we return true. If we can, then we return false. All right, so I think that's all we need to do for that function. So we'll go back to our
And if none of this shit works, just return false. We can't walk on it.
event graph. And now we have this handy dandy can surface the wall ran. And for the surface normal, we want to hook that up to the hit impact normal, I believe, which is just, again, the normal of the surface that we hit.
Okay. So if the wall runnable is true, we need to take our function is wall runnable, and we checking that. I think we're checking this. If is wall runnable, and we'll put in the no this the normal impulse. No, that's not right. That's not right at all. Component hit impact normal. Alright, so we need to go to here, Alt G. Yeah, Alt G that again. I guess that normal impulse is that the F. That's the F hit result. Okay. I'm tripping. As the F hit result dot where's that? Where'd it go? Wrong file. Let's minimize this so we don't get lost. Is runnable. We need to put the hit dot impact normal. What we got? Yeah, that's right.
And we want to check if this is true. If it's true, we're going to continue. If it's false, we're just going to stop executing because can't wall run on it. Another thing we want to check is that we're falling. So get character movement is falling. Because we don't want to start wall running on a wall if we're just walking along the side of it. We want to have to be in the air first. If you don't want that in your game, you can just take out this check. All right, so at this point, we know the wall is runnable in terms of the slope of it. We know that we are falling. And once we know those two things, we can safely assume, well, almost safely assume that we can run on the wall. Another thing we need to check is, well, one thing we should do first is we should find the direction and the side that we're going to be running on. So we have a little function for that, for finding the run direction and the side that we're going to be running on. And again, it's not filled out yet, so we can do that first. So double click on that. And this function is also going to take in a vector for the wall normal, which is just the normal of the wall. And to check if, the first thing we want to do is figure out which side the wall is on from us. So to do that, we can just get our right vector. And we really only care about the horizontal plane of things. We don't care about the vertical axis right now. Yeah. So we want to convert both of these. We want to convert both of these to 2D vectors. So 2 vector 2D. And that will get rid of the Z component. And then once we have that, we're going to take the dot product of those two vectors. And we want to check if it is.
So we take the wall normal, cache it into f vector 2D. I wonder if I could do this. Dot product vector, and we can say it equals the wall normal, right? Can I do that? No. But we can say f vector 2D, we can say wall normal dot x, comma, wall normal dot y, and that will work. Then we want to do the f vector 2D dot product vector 2. Let's just call this vector 1. Call this vector 2. This equals f vector 2D. This here. Get actor right vector, because the right vector returns a x, and get actor right vector dot y. The right vector returns the left or right. That's it. How's it going, Auntie? Yeah, it returns left or right. It doesn't return anything else. It returns +1 or -1. Okay, and then we need to put the float. What is this? I don't know what this would be called, but we'll just call it the dot product float is equal to f vector dot product, and we'll put in dot product vector 1 and dot product vector 2. Shit. So I'll do f vector 2D. Alright. Jesus. Everything works? Alright. So that returns that float. See what else we got. We're gonna normalize that.
Greater than 0.
Oh, we're gonna see if this is greater than 0.
And if it is, then, well, okay, so we'll just do a select mode here. So select. And we're going to be setting the wall run side. So we'll drag that in. Drag this over. Oops. Like so. And hook this up here. All right, so if the dot product, these lines. All right, so if the dot product is greater than 0, which is true, then we know the wall is on our right. Otherwise, we know it's on our left. So we will set.
So in C++, we don't have select nodes. We just got if statements. There is a switch statement, but I haven't learned the syntax for that yet. I haven't seen it used. I've researched it a little bit, but like it wasn't no straightforward explanation. And like I said, I'm new to this, so what I'm doing right now is pretty advanced. Like if I'm looking at this, I'll come back and look at it tomorrow, I'm probably gonna be like, what? Oh, I'm not just gonna be like, you know what I mean? But okay, so basically, we're doing an if statement here. If this dot product float, yeah, is greater than 0, yeah, we need to say we need to set this variable. So run side equals E wall run side. This is true, it's right. Else run side equals E wall run side left. Okay.
That like so. And then the other thing we need to figure out is the wall run direction. Oh, sorry, I shouldn't be setting this here. Just delete this real quick and create a local variable, and we'll just call it side local, so we know it's local. And this is a E wall run side, because we don't, this is a constant pure function. We don't actually want to be changing our variables. We'll set it later. So just set this local one for now, like so. All right, and then the other thing we need to do is figure out the wall run direction. So to do that, we want to do another select off of the side that we're running on. And we're going to take this wall normal. So the one that we got passed in, get wall normal. Just to clarify, this is the same as this, as if I were to drag it over. I think some people are not aware that you can just like right click and get access to the input pins like this, but you can't. But that's all that is. This is just the input pin. And we're going to take the cross product again of either the up if it's right, or the down if it is on the left side of us. Because again, the cross product will give us a vector that's perpendicular to the two vectors that we're taking in. So we're taking in the wall normal.
No, that's cross.
The normal of the wall, and the up vector or the down vector, depending on which way we're running.
So for me, I need to make I can kind of do it in here. So I would make my own f vector here, member variable, that I would set to return the direction. Let's just call this final direction. I'm not gonna set it to anything. So no. F vector. This is going to have to. This is doing with the side, so that the side side multiplier. So side multiplier will equal F vector 0, 0, 1. Right, yep, 1. And the side multiplier here would equal F vector 0, 0, oh shit, 0, come on man, 0, -1. Okay, and then what we're gonna do is get the cross product, and basically what we're doing here is saying direction equals this. Cross product of the wall normal and the side multiplier. And it's going to be the same for this, so I can just copy and paste it. So I don't have to do a select. This is selecting all of this for me, so I can just set all of this inside.
So that will
in
give
the
us
C++.
a vector parallel to the wall. And that is the direction we want to run in. So we need to return some stuff. So click over here on the function and add two outputs. One of them is going to be called direction, and one of them is the side. And the direction is a vector. The side is a e wall run side. And right click, add return.
How long we been going?
Oh, it already added one. Sorry. Get the return node that it added. Hook it up.
Almost 2
and
hours.
This goes here, and our local side that we set earlier over here. Drag that in, and return that.
So I'm gonna finish this one, and I'm gonna be done with the stream.
So again, just to recap real quick, passes in the normal of the wall. We figure out which side of the wall it is from us based on our right vector, and then we figure out which direction we need to run, which is a direction parallel to the wall. And we return both of those things. All right, so back in the event graph, we now have our find run direction and side filled out. And the wall normal is, once again, this hit impact normal, so we'll drag that over and make it straight so it's pretty. Okay. And from here, we want to actually set our variables. So our wall run direction gets set to this, and our wall run side gets set to this. All right, so now these two are set. The final thing we need to check before we can say, yes, we are clear to wall run, is that we're holding down the correct keys. And we need to check that after these get set, because the keys that you need to hold down change depending on which wall you're trying to run on the right or the left. If you're running on the right, you have to hold down D or right. If you're running on the left, you have to hold down A or left. So that's why we needed to do this first. And once we have that, we can call our last little check here for our required keys down. And this function, again, we need to fill out. This one's pretty simple. So double click on it. No matter which side of the wall we're on, we need to be holding down the forward key. So grab our forward access, which again is just a value from -1 to +1, where +1 is if we're holding down W, -1 is if we're holding down S. And we want to just make sure that this is greater than 0. You can use 0, but I'm going to use like 0.1 because if you had a controller hooked up,
if forward access is greater than 0.01 or 0.1, and wall. We check if here. Oh shit, that's not the right if. If, come on, man, you know that's the if I want to use. If wall run side is equal to e wall run side let's just start with left. Right axis and right axis is less E wall run side right. Oh, I love you. And right axis is greater than 0.1. Will return true. I'll explain this in a second. But if all that fails, return false. Oh, else this return false. Else this return false. Because if we're not pressing W, we can't go nowhere else. And naturally, return false. So we get past all these checks and none of that shit is right, we'll return false. Alright, so basically this is a question to say, are we pressing the correct keys? Now, the first thing is if the forward axis is greater than 0.1, which is meaning, are we holding down whatever input button or stick that is required for us to move forward? If that's true, then we check what side of the wall we're on. If it's the left, the right axis needs to be less than 0.1, which I think that's wrong. If we're on the left, the wall's on our left, we need to be holding the key that makes us go left. So we'll return true if these things are true. Else, if the wall side is equal to right and we're pressing the key that makes us go right, we'll return true. Else, we'll return false and naturally return false, because this won't be false. This won't be true unless we physically make it true. So that's how this is translated to human English. But we'll let him finish because I think I fucked up. I think I fucked up somewhere.
The value will.
What's good, Quinn?
You don't want to like barely be pressing the joystick and have it work. You want to actually have some decent amount of pressure on the joystick to be moving forward. So that's why I use 0.1. But basically, it's just saying, hey, are we holding down the forward button or joystick? So if we're holding down the forward button, we can continue. If we're not, we're just going to add a return node. And we need an output pin. That's a Boolean. And we're just going to say return false because we're not even moving forward. Or we're not even holding down the forward button. So no, we're not holding down the right keys. But if we are holding down the forward button, we need to check if we're holding down the correct left or right key, depending on which side of the wall we're on. So to do that, just drag in the wall run side, and we'll use a switch and hook that up. So if we're on the left side or if the wall is on our left side, then we want to take the right axis and we want to make sure that it is greater than 0, or again, 0.1 is probably a better thing to use.
The wall is on our left.
And we can just go ahead and return that. So I'm just going to copy this return node. And hook it up.
I had the math backwards. That just doesn't make sense.
So if we're on the left side of a wall, then we need to be holding down the right key. So if the right axis is greater than 0.1, then return true.
We are physically on the left side of the wall. We need to be holding down the right key.
We basically want to do the opposite. We want to say, just copy this. We want to say if this is less than 0, or even better, negative 0.1, we are going to return that.
Let's put the comments there.
So basically it's just saying,
hey man, ignore that. I don't care. Ignore for today. I reached my time limit on here. Oh, we had a few people come through. Trigger, Bellaquacious, Ishim. I don't know who that is. Appreciate y'all. I'm actually trying to hit the X button. I'm not trying to like it. Okay, so the comments. if we are on the right side of the wall, we have to jump towards our left. We are on the left side of the wall. We have to jump toward our right. All right. Simple enough. Almost done with this.
Just making sure that we are pressing the correct direction depending on which side of the wall. All right, so I think that's all we need. Yes, that looks good. So we'll go back to the event graph. Over here. And we can now branch off of this. And again, this is all happening when we hit something. So we're just checking a whole bunch of things. You know, can we run on it? Are we falling? Are the required keys down? If all of that is true, then we can finally say begin wall run.
Oh, begin wall run.
Hooray. I'm just trying to think if I should make another video. I probably should, because I think this one's probably gone a little long. All right, so I will continue with this in part 4.
Ooh. Part 4, boys. So I've been coding for 2 hours. I'm gonna take a little break, give my brain a rest. I appreciate everybody. Let me get here. So I appreciate everyone that made the effort to come through. Hydra Saf, I was just watching your YouTube. I wish I know who you were. I appreciate you, bro. 2 viewers on Twitch. I need to pay attention to my Twitch. So, yep. As you can see, this is not an easy process. For somebody who probably knows C++, they can probably watch this shit and be like, oh, I know exactly all the steps he's going to do. But me, I'm learning from people who already have planned out the steps. That way I can kind of learn what steps need to be planned out. Like, obviously, I'm not going to get this down in one go, but me personally, I'm happy to be able to look at this shit, look at his blueprint code and say, for me to say that in C++, I have to type this. So, as you can see, I haven't really made too many mistakes. That's a plus for me. But yeah, what my main goal is just understanding as much as I can about the thought process that goes into making something for a mechanic. That way, whenever I want to make a mechanic, I can write out the steps, type them up, or pseudocode them in Blueprint, and then transfer it to C++. Our correct keys down, use standard and to create a pointer to a member. What? Use this to create a pointer to. Oh. Jesus. I'm an idiot. It's a function. Thank you. That should build nicely. I'm able to solve bugs that I see inside of the, you know what I'm saying, the inside of the console. Like, I'm telling you as a person that legit quit C++ because this shit made no sense to me at all. And now I'm able to take what someone else is doing in Blueprint and type it up in C++ and actually see the shit work. Like, even though we didn't finish implementing the complete wall run, it's a 5 It's a 5. Yeah, I forgot I gotta recompile inside the editor. It's a 5 series tutorial, so it's not gonna be. What the fuck is that, bro? Okay, I don't know what. Well, obviously it doesn't work all the time, but I'll figure out what's happening and I'll fix it. But I've been going for a couple hours. I'm gonna take a break. I'll holler at you boys. You feel me? Oh, I don't have that. I don't have that. I got that. Hey, follow me on social media, man. I'll be there sometimes. I'll be checking my shit from time to time. Holla at your boy.